So first let me introduce myself. My name is A. Ishan Rao. I am a PhD student in IIT Tirupati, and I will be one of the TAs who will be taking live interaction sessions for this deep learning course uh, mm, offered by IIT Roper. So the mode of this interaction sessions will be 2 or 3 ways you can look at. First, you might look at that as an assignment solving problem. My approach is mostly to for a more on hands-on technique where we will be developing and we will be coding the stuff whatever we are learning in the lectures, the mathematical, the theory. Apart from theoretical aspect, we will be doing that. So if that is seems useful to you, please please join and let's learn together with respect to this content. And with respect to whatever the recordings of this sessions or any other sessions will be there, it will be provided by NPTEL. Otherwise, I just shared one link in the Google chat in the chat box of the playlist where I will be uploading after the session is over. So once that is when this session is over, recording is done, I will upload in the Google, in the YouTube. If someone still needed it, please anyone from earlier who has seen that link, please post it again. Uh, that being said, today the content that we are going to discuss is mostly we are going to code. Mostly we are going to code NP Neuron and Perceptron class via Python. We will see that as a using one toy example. We will code it using Python, and let's if that seems interesting, let's start with that aspect as well. And if you feel that you still need to know about perceptron learning algorithm, we can discuss that during the class as well. But I'm assuming that you might know. Still, if you don't know, please let me know in the chat section during when we reach there. Maybe in 20-30 minutes we will reach there, 20, 30 or 40 minutes. At that time we will start doing that. Okay, so let's start with few of the things that you might know. I'm assuming that you are very basic in deep learning and very basic in Python. You don't have that much background of Python and all, so we will start with respect to that. Now, the media mode communication that we're going to use is something called as Google Collaboratory. So let me share the screen once. Let me share the entire video. Okay, it's coming up. Awesome. Okay, so there's something called as Google Collaboratory. So this Google Collaboratory is a notebooks. There's something called Jupyter notebooks where you can the notebook will be looking like this. So this has a particular interface. It has some own functionalities. If you don't know anything about this, still fine. During this coding session, you will learn. You can learn about how to use this. It's free of cost. You just need to have a Google account, and following which where we and little bit of Python, because most of the things will be with respect to Python. Whatever we're going to code throughout the course, even the course in deep learning also they might be showing with respect to Python code as well. Okay, so that being said, so this is something called as Google Collaboratory. If you can see, my mouse is clicking here and there. So this is Google Collaboratory. So the advantage of like this is I can write some code here. Let's suppose import OS. I can import some library. I can still use some functionalities of OS or something like that in different cells. So if you can see, I'm writing some random gibberish thing in the different cells. It will run independently, but still they will be connected to each other. Okay, so we will see that how it will work. So there's something called, this is called text section. It's called text section, and this is called code section. Code section where you will run it, and you will be basically connected to a kind of system online provided by Google. So it tells about the RAM. So it has the system that allotted given to me is like 12 GB, which is pretty, or 13 GB, which is pretty good GB RAM, and they have given me space of 107 GB. So it is good for preliminaries for us to understand basic of deep learning or any machine learning coding that you're going to do. If you don't have systems or anything, that is totally perfectly fine. You can still use this system pretty easily and pretty goodly. Okay, now let me share this Google Colab note such that you can also whatever I'm tapping, you can see it rather than the screen. Also, you can see it properly in the Google Collaboratory itself. So let me share this link. So I'm just putting in the chat box. Okay, you can click on it and you can check it. Otherwise, you can open a side window for your system also. Wherever you need, you just let me know, we will stop. Otherwise, what we can do, what we usually do also, from 6 to 7 we will have one session with 5 minutes break and then second session. So in that time also you can copy paste the code. Okay, so now that being said, we will start with the coding of NP neuron perceptron, but before that we will have some certain sections or certain prerequisite that you should know or you should do before directly learning about NP neuron and perceptron before starting using that. So we will start with that. There's certain section with respect to that. So first section is mostly about the data, how you load the data into your system and what are the things you need to do with that data, how to analyze that data. Then second is there's something called train test split. That means once you got the data, you have to divide the data into certain training part and certain testing part. So we will discuss about how to do that, what are the function to do that, why it is important. We will do that, talk about. Now third thing is something called binarization of input. That means MP, it is mostly with respect to NP neuron, where obviously you might have learned by this time that the only inputs and outputs are dealt with respect to Boolean value. So once we get the data, which is a very huge big data and popular data, how you can convert that into a binary class of 0 and 1. Then there's something called inference and search and inference, which where we'll talk about the basic NP neuron faculty, the functions of that, which of that is summation of all the inputs and all, and how you can find the proper parameter using a search function. So and some evaluation using inference, like how the model is working. And then we will deal with respect to neuron class. We will make a proper class and we will use that as a setup for writing all the different kind of classes in this class, in this session or any other session. So there will be a particular format or how to write a code or what kind of function it needs to have for any other algorithm, like recurrent neural network or CNN, which you're going to study in this during the course of time. So a kind of template I'm going to give it to you with respect to that, follow which if needed we can again go through this perceptron class. If you want, we can discuss it theoretically, and then follow that we can start coding it with respect to it. So we will do that, and then there's something called as hyperparameters of epoch, checkpointing, learning rate. So we will talk about that within the context of perceptron learning algorithm, or as a whole problem that we're going to take. Okay, now if you have any question with respect to this, again, if someone has newly joined, for this session or few session, I'm not going to have any assignment question taking it up. The reason being, I'm assuming that you might not even know the simple coding of this, and I'm trying to take a more as a practical approach rather than solving the assignment question. But other Ts are doing it, so please free to refer their lectures as well, the layered driven taxation video as well. Okay, uh, so now that being said, programming assignment, I think it will be there for sure, but I don't know for when it will come. I need to check when it will come. But if it's not then at least this is a very good place where you can start off, because eventually what you need to learn is coding, how to code a deep learning network with with a good amount of mathematical intuition about it, right? Okay, so let's start with the coding again. It's already 6:15. So what we are going to do, we will first import certain data from online, and then we will just analyze in this section. We just analyze how to deal with that data and all. So if you don't know anything about pandas and or numpy array, just look at the certain commands which we use typically most of the time while coding. So there are pretty good large amount of data set available online. So and they are given in a proper standard format as well, so you don't have to download and upload it again. So that is also available through the section of files. There's something called as files in this, and here you can upload the CSV files of data, or there's a in a typical format a data set will be given, you can take that. But if you want it directly online, what we can do is we can just directly import that sklearn data set. Sklearn is scikit-learn. It's one of the famous library for machine learning and deep learning, basically machine learning library. Okay, deep learning is just part of it. So it's and it has a humongous resource of functionalities on which you can maybe at some certain point of time you can look into sklearn as a library in the Google. Okay, so this one thing we are going to import, and there's another thing, this is called as numpy array. So another thing, that whatever you're going to give as an input to a machine is basically numbers or a vector, or basically a matrices or vector, in only these two forms. Now to deal with this matrix and vector, this numpy array will help you with respect to that. It will help with all the addition, vector subtraction, dot product. All this stuff will be deal with by numpy, or there's another library called pandas which we can use it. Okay, so we will going to use this. So let's run it. So when I'm running it, so here you can run it using runtime, run all, run after, run the focus cell and all that, but I am doing shift enter. That's it. If I'm doing shift enter, I'm going below, kind of like it will run automatically. Another thing, let me increase the size of the text for better readability. Okay, I think this would be 150, it's fine. So this RAM and this, if you can see the highlighted part, this should be connected, and since it's free of cost, so the moment it get disconnected, your all data, whatever you uploaded in this will be gone. Code will be there, but the data will be gone, or whatever the output you got. So that is one important thing about the Google Colab. It's a free service, but with certain restrictions. Now the dataset for which we are going to deal with today is breast cancer dataset. It's a quite famous dataset, and many people, there a lot of competition happens only on breast dataset because they are standardized. So many people use it, try and tested dataset. So it is there. So to download it, we will use breast cancer as a variable, and that we will use sklearn dot dataset, which we have imported earlier. Importing means loading the library. Load breast cancer, this is a function already. So if I run it, automatically online this breast cancer dataset will be stored in breast cancer variable. Now if you want to know what is the type of breast cancer, what is a variable of variable it is like, you can use type as a function and just put the breast cancer. So it is given in some sklearn bunch, so it is some kind of data type of sklearn. So okay, that's fine, we will still use it in a different format. So what we are going to do is, once you get the data set, you don't know anything about data set, but since data set is standardized format, it will, one thing will be sure that it will have certain data and it will have certain certain input and certain output, that is x and y, right? So this for any data set you're downloading from sklearn, if you write that variable, that is breast cancer, where the data set is stored, and dot data, so it will put all the input feature value, it may be any other any number of rows and columns, it will put in x, and y will put target basically is the output variable which we want as a output. So we will see what is input and what is output is given in x and y variable. So let's deal with that. So just before that, just let's see what is the raw value of x and y to get an understanding whether we can understand something out of from this or not. So let's say print x and y, it is there. So you get certain values. So what you can understand from here is, this is, let me try to see whether I can highlight it. Yeah, the highlighted part is x value, which is has some exponential value, e raised to 0, 1, e raised to 0, 2, some value is there, and the y part is basically a simple binary class, that is 0 and 1. So breast cancer might be, it might be like whether it has a breast cancer or not, it might not have a breast cancer. Let's assume like that 0 is not a breast cancer and 1 is a breast cancer. Let's assume for now. Okay, but still I am not getting some sense of the data, because too much new number I am not getting proper understanding. So what we can do, first we will try to see what is the size of input and output, that is what is size of x and y. So for that we will use and also if you since I converted this here, let's see the type as well. So what is the type of x right now? So if I just do type x and type y, because I stored the breast cancer data and target data, which is something called sklearn, some kind of data format is there which we don't aware of, but we should know something which it should be converted into some format which for which we should be aware of, right? So okay, now it is showing that type of x and y is numpy nd array, that means it's a numpy array. So which is pretty good. Most people use this, put the data in the numpy array, and it's basically a simple array. Numpy is not any different, it's a typical simple array. If you have done the coding in a contiguous value, it is like this only, nothing any fancy with respect to this. Now once you know that the type of x and y is basically numpy array, now we will see that what is the size of x and y, how big it is and how many values it has. To do that, there is something called as shape. So if you write x dot shape and y dot shape, so it will give you certain values. So let's try to understand what this value tells. Now 569 30 means the x data, the basically the input data set, or not input, the input data that we are having, that which is the actual data, it has 569 rows and 30 columns. Okay, so the x has 569 instances of certain values, and these instances has been told in terms of 30 features. So for example, if you look like, if you have a phone, let's say you want to have a phone data set. Now phone data set might have features like price, screen size, battery, right? Screen size, battery, and whether it has camera or not, right? So multiple this thing. So whatever I wrote here, it is called as features, and features are usually columns. You put that in column, and if I write for one phone, it will be, if I write for one phone, it will be one instance. So I have 569 instances. I have 560, maybe I have data of 569 women who might be have breast cancers. So who might or might not have breast cancer. So but I have a data of those 569 women, and I'm trying to understand the breast cancer data set from 30 different features. So what are those features? We will see. Now that being said, this is for 30 features, right? Now for y shape, you just see that this is only 569, because it has only 0 and 1 value, that is yes and no value. That's why we don't have multiple columns, and usually the output the column or the output data which we are trying to predict is usually a one column itself. So that's why for 569 instances I have only 0 or 1 value. That's why y dot shape is only 569. Okay, now if that this is this thing you understand as a that, okay, now I have a data set in which for 569 people I have some data with respect to their breast cancer. Okay, now to understand what are those features which we are talking about, what are those 30 features we are talking about, for that we might to get that we might use another library which is called Pandas, which is very famously we use it. So what we can do is we'll try to put whatever x and y values, or basically a data set that we got in a data as a data frame. So it's like data frame is nothing but a kind of tabular value that you will get, which is present given by the Pandas. So to do that, same like x and y value that how we did. So best answer dot data will be the x value, that is the input data we are giving, and for columns, since we want to know the column, each and every column names, so we will write cancer breast cancer dot feature name, feature names. Okay, now let's I whatever data we got as this data that we got from downloading the breast cancer thing, we are going just converting them into pandas data frame with the name of data. Okay, we will see which kind of variable we are going to use for processing, but just now, just to understand what is the data we are having, we just let's understand from that perspective. And now the output column, which will be the actual thing which we want to predict as 0 and 1, we will store in we will add another row that is called class, because here we take breast cancer data and it doesn't usually have the output column or the output 0 1 value. So what we are going to have, we will add another in this only another column which is named as class, and we will just put breast cancer dot target. So target variable that we are going to have, the output predicted output thing, we are going to put that in data. Now once our whole data is put together in the data variable, their data frame, let's see some of this value. So to do that, we will use data dot head, which will show first 5 rows of the data set. Okay, so if we run this, okay, so earlier if you see, it has shown 31 columns. The one extra column is coming because of class. Earlier it was 30 in the input data set that we taken already, and it has, we added one class for to put the target variable also, so it is there. So that's why it is 31, and we are in first 5 rows of data set. So the features that we are talking about, the 30 features, it is something called as mean radius, mean texture, mean parameter, mean area, okay, mean concativity. So we don't need to care about what are these features about, but we just get an idea that okay, the multiple features which talks about the about maybe that it talks about the tissue of the breast where the actual the cancer is might be growing. So they are just trying to measure those things, and they might have measured using 30 different features value, and they are just presenting it and using 30. After this, that is after worst fractional dimension, till here all the there will be 30 number of columns, 30 features. After that, the last column is class, which is a target variable which tells about 0 and 1. Okay, now we get some sense of the idea that okay, we have 30 features. Of that 30 features for finding breast cancer or not, we have 569 instances. Okay, now once you had this, if you want to know little bit more about these values as well, what is the some understanding of mean radius, mean texture also. So there's a function in pandas called describe. So if you just write data dot describe, you get little more better understanding about the data that you're dealing with each feature. So for example, the mean radius that we are having, okay, so mean radius throughout that 569 instances, you have 14.12 some kind of maybe centimeter or maybe millimeter, something like that, kind of radius. Texture is something 19.28 something with certain value, maybe centimeter, millimeter, or some value, some scale will be given to it, that which we don't need to know as of now. But describe will tell you overall aspect of the data set with respect to each and every feature. All the 30 features you will get to know about it. Okay, so the about tells about 569, that means the data set is proper. That means for each instance and for each instance and for each feature I have data. There's no empty column or there's some not gibberish data of a and abc which can hamper my understand or hamper the machine to learn the model, learn this data set. Okay, so this is typically good enough with respect to this. Now once you get this, now our understanding is also, if you want to know, is about okay, I know that I have 30 features and 569 instances and all, and you have 0 and 1 class. So I just need to know that how many instances are in 0 class and how many instances are in 1 class. to get to know, to understand that part, what we can write is, so we can print one thing. So we just take from data, which is a data frame. From that data class, we are going to use a function called value counts. So what it tells, okay, oh sorry, my bad, value counts. Okay, so it is telling me that the class 1 maybe which might be a cancer, it might be 375 instances out of 569 where the value is 1, and for 212 it is the value is 0. So certain amount of maybe 60-40 kind of ratio is there, where 60% data is counts to output as 1 and 40% might be outputs as 0. Okay, now that is there, still we don't know what is the actual 0 1 means. So to do that, we can just write again breast cancer as with the data set, the actual data set that we have taken, and target names. So if we just want to know the column names or the value names of what mean by 0 and 1. So 1 means malignant, that means it's a serious case or serious case of breast cancer, or benign, that is it might be pretty treatable kind of thing. It's an initial stage of breast cancer. So 0 means benign and 1 means malignant. Okay, now once you have this also, now what you want to do is, okay, I got this data of data from describe about each and every mean, radius and all those stuff. What if I want to know from with the respective of the classes 0 and 1, how the feature deal plays with it, what is the mean value of that, suppose. So to do that, we can use a function called group by. Group by is available in Pandas. So data dot group by, class is the we are taking class as a column, that means it has only 0 2 values. So we are going to group based on the 2 values, that is 0 and 1, and we are going to find mean for all the features. Now if we can, so here what is saying, for the class 0, the mean radius of the mean value of mean radius feature is 17.46, and for the first class, the one class, that is malign cancer, this thing, it might has 12 point something. So it's just giving a mean value of cumulative mean values, all the rows which belongs to 0th class, or and all the ones which belongs to all the rows which belong to first class, and is giving mean values with respect to each and every with each and every feature. So you get to know that there are multiple ways through which you can try to understand a data. Now you get to know that, okay, I have taken the breast cancer data. Now you know that they are in the input there are 30 features. There is only binary classification of 0 and 1, which is called malignant breast cancer or benign breast cancer, just like that. And you have seen the group by of how the data has been divided of in the class of 1 and 0, and with respect to each class, what is the mean value of each of the features. So using this multiple ways, you can just try to get an overview of the data, just that you know that which kind of data you're dealing with. Okay, you get that proper understanding with respect to that. Okay, so this is about loading the data and just analyzing the data, how it plays out. Okay, now if you have any question with respect to the loading data, please let me know with respect to this. Then we'll go to second section of training and test split. So let me see the chat section if you have any question with respect to this loading data. So if you have any question, please let me know. Okay, so if you have, please put down in the chat section. Is this still come under EDA? What is EDA? Can you please elaborate what is EDA? Exploratory data analysis. You can consider it like that, but obviously data analysis is something a prerequisite for any machine learning model you're trying to create. You can't just take it and this thing as an input and just you just give it to the model and it will try to understand something out of it. So we will again try to see that. I will again come back to this at certain point of time to tell you that why this analysis is important when we are trying to see the MP neuron or an perceptron model. how the value changes from the perspective of how whatever analysis we have done. Okay, data cleaning we will do, not in this case, but we will do mostly in the terms of to format the data into a particular format. Right now, if you can see the data here, in this case, yes. Now I have something floats here. Okay, it has a mean radius is in certain range of maybe 15 to 20. Then the mean parameter is in range of 150 to 120, kind of like that. Smoothness is between 0 to 1 or 0 to 0 to 0.5 or 0.1 to 0.5. So the ranges are different. So how to deal with this kind of data where you have multiple different ranges and how to make it standardized. So that is something we are going to deal that for sure. So loading data is basically about how you can directly take a sample toy data set from the library called sklearn or any other data set, and you can play with it to understand, just to get to know about what is the data set is present in front of you. And then we will, so our main, by this time if you can understand whatever discussion will happen, we will, what NP neuron perceptor neuron will try to understand is, I have 30 features with me and I need to predict for a given any test data that I am getting, any row, whether it will, whatever the values I am giving, with that can my MP neuron model can predict whether it is a malign breast cancer or benign breast cancer. That's a basic data set, basic understanding of the problem statement that we are going to through using NP neuron and perceptron. Okay. So data analysis will be there with respect to cleaning and all, that is absolutely true, but not to that extent, because most of data set by the time you will get will be clean, but still it's a very good practice to know how to clean the data and all. For this, since it's the first session, we are not going to focus much on the cleaning of the data, but we will see how to convert the data into a particular format. Okay, now let's go back to second section, which is train, test and split. So again, train, test and split is basically, it's what the, if you are very new to ML, if you don't know this terminology, it's basically about any machine learning model, and machine learning model means any deep learning or MP neuron perceptron model also needs some training data to learn. Okay, so which we'll get it through train data set. Okay, and then once the model is been trained, it needs to be evaluated on a different data which is not coming from the trained data set. So it will call as test data set. Okay, so the test data set will be different from the trained data set. Suppose I have 100 instances. So what will happen is, I will maybe give 80 instances for training and the rest of the remaining I will use for testing. Okay, so that is what training testing is there. Since by default data set doesn't provide training and testing split, they have given us the freedom to basically try the testing size according to our needs. So basically I am saying that instead of 100 instances that you are having here, I might say 70-30. 70 instances I will use for training the model and 30 I will use for testing, or maybe 90 instances I will use for training the model and 10 I will use for testing. So that is something, and freedom has been given to us with respect to that. So how to do that? Now once you find that, okay, I have a breast cancer data set, it is in there in X and Y format. So how to do that? So there is a function in sklearn, so let's import that directly. So which is called model sk.model selection, in that train, test, split. Okay, so let me add code here. Yeah. Okay, now I took this as this train, test, split. Now already we have X and Y taken from the earlier cells, this X and Y, but still we will, since we are using pandas right now, so let's start with the pandas as a continuity, that it is given as a, now it is given as a table for us, right? So what we will do from that pandas itself, we will try to extract x and y. So what we will do, x is equal to data dot drop. So from data I am dropping a particular column which is class, which is a basically a target variable of 0 and 1, and if I will use, I to tell that I need to remove that column, I will use axis 1. So if axis is 0, that means you are removing a, removing a column, removing a row. If axis is 1, you are removing a column. Now once that is done, now y equal to data class, because y is the output, that's why we are putting whatever data dot class is there, we will put that in the y. This is a target variable which we are aiming to train and predict the values of the y. Okay, target variable. X is input variables or input features. X is input features. Okay, so let's have this like this, and I need to add again a code, this thing. Okay, now I have x and y. To get to know that what is the x is basically like, I will just show you the shape of that. So I will just write okay, before that I will just split the x train y train kind of thing. So I will write x train. So it has to be written in a particular format, that is you have to write first x train, then x test and y underscore test, say train, and y underscore test, then train test split, and then you give x and y, that is input and output variables, you give like that. Automatically from this function train test split, automatically from x will create x train and x set, and from y it will automatically create x y train and y set. So we are not telling how, what is a split is like. So let's automatically we'll see what is it is how it is splitting. Let's see that. So to do that, we will just use, we will try use the x shape function, that is x dot so we can take like this. Okay, just to know the x train and this thing. So x shape, x train dot shape, and x test dot shape. So we just want to know how many rows or how many instances has been divided into train and text, train and test. So if you can see 426 instances with 30 features of column obviously has been given to train, and 143 is given to 30. Okay, now ideally it might be okay, but since we 569 instances are actually pretty less. So actually when you start going and developing the machine learning models and all that, you will be dealing with millions and billions of data rows and all. So when I'm saying rows, basically these instances, right? So at that point of time 50 60 70 80 60 40 split is okay kind of thing. But here since the data itself is very less, it's in 500 600, so it's better that we will train the we will split this thing in the terms of 90 and 10. That means 90% of instances we will give it to train, and 10% instances we will give to test data. Okay, now once we have this, to how to write that okay, I need 90 10 split kind of thing. To do that, let me copy this code, add it, and in this test train split I will add another function which is called as test size. Now test size I will just give as 0.1. Now what it tells means, out of 1 I will take 10%, that is 0.1% from the data set, I will put that in test size. That's the only thing. Now if I run this, and again I will run this command of x shape just to know the what is the shape of the train and test. So now it has given me 90% instances, that is 512 instances for x train, and 50% 57, that is 10% of the instances from 569 as to x test. So we have done into 90, just let me write it down as a comment, 90 10 train test split. Okay, Now once you get this idea that okay, now you can see that okay, my data has been splitted according to the my wishes with like whatever split that you want. Now what you can do is you can observe another thing. Same y test will also, if you want to see the how the y test will be like, um, this is another way of understanding certain aspects of whether splitting is correct or not. So we will look into that as well. So let me first show you the train test for the target variable. So it's same 512 57. So it will be in line with whatever how it has been splitted the input variables. It also split the same way to the output variable as well. Now once you have this, let's try to see the certain aspect of it. So like suppose now you have the variable of y shape and all that. Just try to understand of what is the mean of that input variable out target variable, and why we are doing that, just let me explain you. Just let me try write it down. Y test train and y test mean. Now okay, now what we are saying here is this the general dataset mean of for the target variable for the 569 instances is 0.62. That means there's some standardized some standard value is there with respect to this, with respect to dataset. Now train is or train the training dataset is almost similar to that, but what we can see interestingly that the testing dataset that we are created just now has higher mean. Now what the complication it will arise, what it will do is, the complication what it will give is that there might be certain instances, certain values of maybe 0 or 1 which might be more in test and less in train, but we don't want that. So what we want is that suppose a training data set has 80-20 split with respect to 0 and 1. Okay, so let's just let me write it down. In the training data set, as you have seen in y target variable, you have two classes 0 or 1. Now 0 1 is there, so how it might be, splitted like that, maybe 50% or maybe 70% of uh, rows which is belong to 1 are present in training, say, and 30% are remaining of class belongs to class 0. Okay, now once you have this, we want to preserve this values of 70-30 in test data set as well. So what we want is, in test data set, we want for the y value also that the number of 0 and 1 which has been distributed suppose in 70-30 ways, I also want in the same ratio in my test data set. Now why it is needed? The reason it is needed is there is a chance that if suppose if I have 90% of the ones in the training data set, only 10% of 0 here, and here it will lead to I have maybe 80% of zeros with me of 0 class and only 20% belongs to 1. Okay, now it is giving me a very it might give me a very bad accuracy. The reason being, I have most of the data has been trained on the classes of 1, but when I am testing, most of the data, whatever the instances I am giving is 0. So obviously the chances are that it might predict wrong for the instances where the actual class predicted class is 0, but it is giving 1. We don't want that kind of scenario. So that's why even in test train means also we want to preserve that whatever the output class is there, that is 0 and 1, in whatever ratio it is present as it is. So let's say 40-30 or 90-10 kind of that, we want to preserve same number of instances in test also. So how we can do that? To do that, we will use something called a stratify. So let me again copy this. Okay, let me remove this as well. Okay, now once you get this test size as according to your need, what the stratify do is stratify, and you have to tell the which variable or which target variable or which input variable you want to deal with. So here I am giving y as a stratify. So what it will eventually do is whatever ratio my test train data set has in terms of classes of 0 and 1, whatever the ratio it has, same ratio will be maintained in test data set as well, such that the bias will be reduced from the while training data and testing the data. So that is just to prevent the bias or overfitting of the data. That is some terminology that you will learn again in the future, just to get understanding that bias. You might know in the simple word English, bias means I learned most of the data on class 1 and I'm testing on class 0. Obviously, chances, since I learned on 1, I will tend to predict more as a 1 class rather than 0 class, right? So that is to prevent the stratifies there. Now once you do this, let's run this code. Now if you do this, and if I run this code again, and if you check the mean, now you can see that the ratio of all the training and test means is now it became kind of equivalent, at least not exact but equivalent. That is, it is in the range of 0.62 or 63, so which is good enough for me. That means the classes of 0 and 1 has been properly distributed in training and testing data. Okay, now once you have this also, same thing you can test uh, for input features as well. So what you can do is, let me again copy this, x mean, x train, and you can see the same aspects in the uh, in this all the mean values as well. So for example, my mean radius for the whole data set is 14.12 something. Now when it comes for training data, it's 14.13, which is typically fine. Similar and for testing is 14.067. So the based on mean data, we are just trying to understand that the whatever that the distribution having even train and test split, it is done properly even, right? So this is what about we can tell about mostly about training and testing split, how we can maintain the equal ratio about all the classes that we're trying to learn, in this case 0 and 1 as a class. Now another point which you want to remember with respect to this training and testing is that, okay, whatever you are seeing in my screen, can you reproduce the same in your Google Colab also? So whatever I'm writing right now, can you do it in your own as well? So let's see that how to reproduce it. So in this train test split, there's another function which is called as random state. So what random state is doing, it's just you can give any number, but suppose I'm giving one number right now. Whatever you're going to write in your code also right now, if you're writing as it is when I'm typing it out or any other thing, you will see that whatever the values I am getting right now, you will also get the same values. Why? It is the random state will presume that the randomness will reduce. So whatever I'm giving here, if I instead of 1, if I give 40, the number doesn't matter here actually, but it will give that whatever I'm typing here, and when you are typing in your system, you'll find the same values to validate that, okay, whatever results I'm getting, you also getting the same results. So that's the reason of having random state. Random state is basically for reproducibility purpose, because if I give you this code and if I don't give random state, there's a high chance that whatever the results that I am getting, you might not get it. That's why to reproduce it should reproduce in your system. Random state is important as a factor. Okay, now once this is done also, so this is part of section 2. We're talking about most of the train test split. So by this time you get some intuition or some getting a little bit idea about that even a train split is not something you just divide the data just randomly into certain 70-30 80-20 kind of ratio. In that also you have to understand the nature of the data set, and you have to make the proportion of data set split in such a way that the training and testing of that data, when it will happen by the model which has been we are going to train, it should be equivalent. It should not lead to some kind of bias. Okay, now before going to binarization of input, let me see if there's any other question with respect to it. Okay, this is for, okay, this Jay Prakash, I think given this one, I think this was this for perceptron learning algorithm, right? Okay, we will look into that. Previous class note also, like this one YouTube link channel I've given where I will uploading this because I think NPT is little bit giving a delay. So please, anyone who has taken the YouTube link, please post it down there. In that also, there's a link for whatever I have written earlier. Also, it is there. Okay. And now, is there any benefit of using pipeline API of scikit-learn in place of train test split, which have fewer data, test and train? Yes, obviously. Like now, these are very basic stuff with respect to what we are dealing with. Unless you understand this basic of train test split, you can't directly use the pipeline of aspect where you just need to put certain code and automatically everything will happen. So yes, pipeline is very useful, and it just save our time to write all this code that we are doing, but just to get an understanding of how even a training and testing happening within the model is something many people might, if many people, I'm assuming many people might not don't know. That's why we are going explanation is there. Okay, where is the dataset link? So if you can, if someone can give it to the Google Colab link, we are directly downloading through online using sklearn. So we are not uploading any dataset. We are, so using sklearn dataset, we are directly downloading the breast cancer dataset using a function. Okay, so please, any one of you from the class, please post the again Google link and the Google Colab link here, such that the others can look into it. Now, let's finally go, because we have 4-5 section also. How to use pipeline right now? If you know this, then I can tell you. If you don't know this, then I would not suggest you to use any pipeline aspect of this right now, because that's an advanced thing. If you don't even get to an understanding of how even a basic loss function evaluation, everything is working, how the model, don't jump to pipeline as of now. That's my suggestion will be. Okay, now with respect to binarization of input. So what do you mean by binarization input is, now I am doing it with respect to yeah, I am doing it with respect to NP neuron case only. This is only for NP neuron because perceptron can take real values, but NP neuron can take inputs must be in Boolean values. So binarization means 0 and 1, converting all the data into 0 and 1. Okay, so that's the binarization of output I'm going to talk about here right now. So before this, let's quickly see how the data will look like as a plot. If you plot it, how the data will look like, just to get some idea about it. So to do that, we will use a library called matplotlib dot pyplot as plt. Okay, and let me run this, and if I want to show how the data look like, let me take the X train, and dot t means I'm just transposing it. Basically it will be shown as a y. I want to put it on the X axis, that's why I'm doing this. I'm storing the data points at star, and to know that which value is shown to which feature, I'm just using the ticks function. And to rotation is basically that how the feature name should look like in the x-axis, for that, and plt.show. Now once okay, the code is already shared right now with you. So the Google Colab link which someone has shared right now, I'm just typing in that code itself. So you can please look into that by clicking on that link. Okay, so this is how the data set look like, and it has some 30 features, and mean radius, mean parameters, mean smoothness and all, and the ranges is given like this. Now we can see that lots of data has been uh, in the range of from 0 to 3000, 4000, kind of like that. So to binarize it, let's assume for now, for this code sake and the class sake perspective, that anything between any value for any feature below 1000 I'm considering as a 0, and anything above 1000 I will consider as a 1, because I need to convert as a 0 or 1 value. I'm just going to assume this as a condition, that for any feature, any value which is below 1000 is my 0, and any value above is 1, kind of like that. So and when I'm converting this, I'm converting from the perspective of feature values, not as a target variable. It is for converting the values of feature values that we have seen earlier, right? uh, so we have seen the feature values of 17, 10, 122, 1001, 0.11 and all. So they are then, these numbers are float numbers and they are present in very different ranges, right? So I'm just going to convert them either 0 or 1 value. That's it. For each instance I'm going to convert that. Okay, that is what we call as binarization of input. Now once we're going to have this, so let me write the code how to do that. So again, I'm stressing out the binarization of input is just to make each feature value as 0 or 1, because NP neuron can take only 0 or 1 as a value. So to do that, let me take new variable, the x binarize, and x binarize train. I'm just say 3 train. Okay, it's 7. Okay, that's fine. Okay. Uh, okay, after this, maybe take 5 minutes of break for all of you. Just let me complete this part quickly. So I'm just giving any standard name, any name for to the variable x binarized 3 train kind of thing. So x train mean area. I'm just going to show you for mean area first, and then I will show you for how to do it for all the one. Okay. So for x train and for the particular column of mean area, I'm going to use a function called map from Python. In that, I'm going to write a lambda function where a function can be written in a single line. So for if you use lambda as a keyword, it will invoke. So it is saying that for any x value, we are going to take from mean area, that is 0, the value will be 0 if x is less than 1000, else the value will be 1, kind of like that. Okay, so I'm showing for a one column, and then we will see how to do for all the features, or for one feature I'm showing. Now if I want to plot it for this one, so I just write x binarized 3 train and this. So for one column I'm showing this. So if you can see here clearly a little bit properly, this is so only one feature, that is mean area. So all the values have been down towards to 0 or 1. There's no in between. If you want to see earlier how it was, for the C, if this mean area is there, where the line is like pretty big from 0 to 2000, 3000 values going, but we have divided this value into 0 and 1. Okay, so that part we have done. Now what we can do is to do it for all the values. So we have to use something called as Pandas function. So let me do that. So this is something called Pandas function of cut, name as cut. So let me write is that. So I'm doing for all features right now, not only for mean. So how we can do? I will use x train dot apply. Okay, pd dot cut. Pd dot cut is a function which has been called. If you don't able to understand this function, that is still only fine. I'm just try to get understanding of what in overall I'm trying to do. So what I'm trying to do is, our values are in different ranges. We want to convert to 0, 1. Now this is the output which we can look like for a particular column, but we want to do for all the features of particular one feature called mean area, but we want to do for all the 30 features. To do that, we're using the function called bin cut, which has bin of 0, bin called bins equal to 2. That is, you have to divide that whole data of a particular feature into 2 bins, and label is 0, 1. Now here we are not defining anything that whether it should be greater than 0, greater than 1000 or not. It will do automatically for that particular range of values. So we don't have to care about, everything will be taken care by PD cut. Okay. Now once we do this, label 0 and 1. Sorry, I did 1 and 0. So I'll just do 0 and 1. If I run this, okay, now to see how the data will look like, let me copy paste again the earlier code. Okay, sorry, I need to change this as X binarized train. Okay, so for each value, for each feature that we are having 30 features, we have divided the whole data into 0 and 1 value right now. Okay, so this is what we are trying to do with respect to this. And now our next part will be to use this data. Right now it is in pandas form. How? I will just show you that. We will use it into numpy array, because that will help us properly to deal with all the computation we are going to do for the next NP neuron thing. So just to tell what is the type of X binarized test, this is sorry, train, my bad. Okay, this is train and this is for pandas. Okay, now since we have done this for training function, that is we have converted all the training data set into 0 and 1 for only for training aspect, but we need to do for test data set as well. To do that, just I'm copying paste earlier and I will just writing this as X test. Wherever test train is there, I'm just changing to test, and same thing apply, need to apply. And if I just do this, it has happened for test as well. Now what the only thing I need to do right now is I need to convert this pandas into numpy array. So let me do that as well. And so the reason we are converting to numpy array is basically for better computational value, because we are right now it is in data frame format, we need in a proper array format. So binarized, if you just put as train dot values, it will automatically convert into numpy array. So if you want to see type X binarized test, it will show as numpy array right now. Okay, so we will take 5 minutes of break here, and then from here, from inference search and NP neuron class, we will talk about quickly try to do NP neuron class. Once that is done, we will, once this format is done, then we will do for perceptron if the time permits. Otherwise I will give you the code, proper code, every single thing, or if you want we can extend the little delay and we can see the how to write perceptron class as well with respect to this learning algorithm. Okay, so we can take 5 minutes break. So right now it's 7:06, maybe by 7:07. So maybe by 7:10 or 11 we will start again. And now we will actually going to write the code for MP Neuron. Okay, so this is all the preparatory steps just to get you understand that even before actually writing an algorithm, using any ML algorithm, you need to prepare the data properly. You have to analyze the data properly. So that's the crux that I want to say from the session 1 of this today's class. Okay, let me check the, yeah, I'm going to summarize one more time. Okay, PD cut also. Is there any chance of information due to data pre-processing? Touch pandas summary. Okay, so I will tell you the data information loss as well there, or is there or not. Okay, so let's start with summarization of what we have done till now. So what we have done is we're going to basically our aim is to write for we're going to write a code for NP neuron class basically, and if per time per perceptron. To do that, first we have to load the data. We should have some data set with us. So what we have done, we use sklearn dataset. Sklearn is a library. From that we taken a breast cancer dataset. Now once we get the dataset, we should try to understand, because we don't know how the dataset look like. Most of you don't know. So first what you need to do, you have to analyze the dataset. Like you should know what are the features of that, what are the input data, what is the output data, what the target variable look like, is it a 0 1, which we know right now it's a 0 1 as a class, but it might have multiple classes as well, 0 1 2 3 4 5, right? And how many features you have, what are the nature of that feature. So first what we did, we tried to understand the nature of that feature with the help of pandas and numpy array. So this is the data set would look like, where we have 30 features, and each feature has different ranges of values dealing with, and at the end it is from all these input features, it is just trying to predict whether my class, whether I have a breast cancer, whether the breast cancer is malignant, that is 1, or 0, that is benign. Okay, 0 means very less or nil chance of breast cancer, and malignant is serious chance of breast cancer. So this is how we try to just to get an understanding of the data set. So once we get the understanding of the data set, we will try, what we will do, the next step is, you know the data set, now you want to train that, you want to prepare the data set, that okay, I want to split the data set in such a way that my proportion of whatever data I am giving in a training should be equivalent to the testing also. It should not be like that I trained the most of the data on the class of 1, but I found that the most of testing data set is on class 0. Most of testing data set contains of class 0. So it will give me very bad accuracy. What I want, the number of the proportion in which the number of class 1 and 0 instances are present in training data set, I should also need to have it in test data set as well. So to do that, we use something called stratify. Okay, test size will tell us about how to divide the data set into training and testing according to our needs. Okay, and the last thing in training and testing is something called as random state. This is for random state is for reproducibility. That means I wrote this code, now you're going to apply that after this class, you're going to again try this, and you find that whatever the values I am getting is different from yours. It should not happen that case, right? So that's why we just need in train test split function, we just write random state, and you can give any number, but keep the same number. So for example, if I'm keeping 40, you should also keep the random state value as 40. Then you can see that whatever the value I'm getting, you might also getting the same value. Okay, this is a train test. Now for NP neuron, you know by theory lectures that inputs apart obviously output is 0 1 as a binary or as a boolean value, even the input should needs to be 0 and 1 value. But what we have seen from the earlier data set, that it is ranging from 0 to 4000 values, so it's a quite big range. So what we need to do from binary of data set is, we will convert for each value of each feature, will convert into either 0 or 1. To do that, we will use a function called PD cut, because right now we're dealing in the data frame aspect. So what PD cut will do, it will analyze the range of the each feature. So suppose the particular feature is mean area. The mean area starting value is 0 and the max value is 1000. So it will automatically, using its own algorithm, try to identify a range from which it will say that okay, below this range I will assign any value below this. So let's say 500 as a threshold. From 500 threshold, I am assigning the value as 0, and above value of mean area above 500, I will assign as 1, like that. So for it has done for each and every feature. Now since it able to do that for each and every feature, now the data set will look like that, either 0 value or 1 value. Okay, now once we do that using PD cut, we get this data. Now the last step what we did is, still the data set through which we are dealing with is in pandas. Now basically a data frame. Now what we want is, we want it as a proper array, because we are going to write a proper learning algorithm of NP neuron, and it requires it as an array. That's why we converted that X bandarized test into dot using dot values. We converted that data frame that is coming from pandas to numpy. It's just changing of the from one format to another format. That's it. Now maybe in 2-3 minutes, okay, it's already summarized. I've summarized in little more time. Give me 2 minutes time. I will take a 2 minutes break and I'll come back. But you get a gist of with respect to this. And yes, the question is there any chance of information loss due to data processing? Answer is yes. It will be there, it might be there. To what extent, we don't know. But since it's a simplistic case, we are trying to see that how we can try to deal with that. Okay. Right now, you don't need to consider about information loss as of right now. okay, because there are some technical standardizations and all which takes care of those stuff as well. So for now you don't need to consider information loss because you're converting the data from one format to another format. Okay. Okay, that being said, give me 2 minutes, I will come back and then we will start for the NP neuron. Okay, and if you have any question, please just put dot in the chat section. Okay, again welcome back. So let's start with where we are left. So now we have seen all the dataset processing and all those stuff. Now we will start to write uh, we'll start to write code for NP neuron as well. But before that, just try to get some understanding of how you can do as a brute force or as a natural thing by a code, that just try to predict based on certain values. So you might know that in a NP neuron, the only parameter that you need um, in NP neuron, the only parameter that the model has to learn is parameter B, which is a threshold value, right? And G, the function G is basically sum of all inputs, right? So this is the basic function G, and this B is threshold. So whenever the sum of let's say x1 plus x2 plus dot dot plus xn, if it is greater than b, which is a threshold value, we'll assign the value of 1 from the y class. Okay, otherwise we will give 0. This is the basic NP neuron function. If it is less than threshold, we will if it's greater than equal to, we will give 1, otherwise less than threshold we will give 0. So basically that's how a typical NP neuron model was there, the simplest model. Now just to get an basic understanding of that, like how we can do that, let's assume, because there are 30 features are there, so I'm assuming that let's take a threshold value as b equal to 3. Okay, now I want to know that whether if I take any random instance from the data set, whether it will giving me correct answer or not. Okay, so how can I do it? So I will just write np.sum, if np.sum of x binarized string, and binarized means all the features here are converted to 0 and 1. Okay, if I do this, and I'll just take a value 100 instance, like I have 569 instances of that 100, whatever the value will be. So I can write it using this comma and this, so I can take only one row value. I will take that this value as 100th row kind of thing, and I will check I will sum all the features values, and I will check whether it is less than or greater than threshold or not. Threshold is b in this case. Now if it is the case, I will just say NP neuron inference is malignant. Okay, which is greater than equal to, else I will just say, let me copy, NP is benign. Okay, so if I just do some random, just I take a random threshold and I just try it on a one instance. So let's see how it will run. Okay, the NP neuron is benign. Let's say it is saying that okay, my values, whatever sum I'm getting from all the inputs is greater than sorry, it is less than 3, so that's why it's showing me benign. So let's see what is the actual output of it. So to find that, you just need to employ the y train value, and let's give it as 100 because the value is 100 here. Okay, and equal to, if y train is equal to 1, I will just printing that. Let me just take all this as it is, copy paste. Okay, I will just say um, ground truth is malignant and ground truth is benign. So what I am trying to do right now is basically I'm just taking any random sample from the data set. I'm just checking that if I take any given threshold as B, how it will going to look like. Okay, so right now it is giving me that okay, for NP neuron this thing, the both answers giving correct. So we might assume that 3 might be the best threshold. So but let me assume, let's like 128, 127, and here also we'll say okay, for this also it is perfectly working fine. Okay, that's fine. Let's, instead of trying multiple things, I will write a code where we can try and test it randomly. To do that, I will just use a random function here. So I will just use from random import rand int. Now once I have this, I will take this. So what I'm doing, I will try for any random variable, any random instance of the training dataset. I will see that whether it's giving me proper values or not. Where is the instances where it is where it is falling with the prediction, right? So to do that, I'm just giving 0 as a starting point, and it will give me random integer value between 0 to x dot binaries dot strain dot shape 0. So when if you put 0, it will tells that it will give me the number of rows that has rows or instance rows are present in the training data set. So might have seen the 512.30 comma 30. So out of 0 to 530, it will give me any random row value. So I will just put this as I, and I will put this as I, and yeah, I think that's it. If I put this, so let's see how it will work. So for any random value, it is showing me this. Again, if I run this again, random. Now here you can see for any some random value, I didn't print I value, but it is showing that the MP neuron is giving me a different answer and the ground truth is actually different answer, right? So we can see that B3 might not be correct in certain cases. So what we can do right now is to understand that how good B3 is, let's write another code with respect to this, just to get an understanding that if we take one threshold value, how good it might be. Okay, after that we will automize it to choose a particular B value as well. So let's build an intuition base with respect to this. So we have accurate rows. I'm just keeping some values here. Now what I'm doing, I am taking x and y value from x binaries test, say x binaries train and y train. Now to better understand which one will do what, we will use a function called zip from the existing Python library, which it will say that for x value will be taken from x binaries train and y value will be taken from y train. Okay, now once we have this, I will just do a simple prediction how I will do simple prediction, that was I will do np dot sum and np dot sum of x value, that is the input value that we are going here. We have done the same thing, right? X binaries for a particular row, same x np dot sum we will do for any particular row of x, and we will see whether it is greater than equal to b or not. Okay, that's the only condition we'll put, and then whatever the value we'll get, either 0 or 1, we will put into y prediction of training. Okay, so when I'm saying y prediction of training, that means whatever the value I'm getting for the training data set, I'm storing it into y prediction train. Okay, and and appending the values in the using the ypred where the values are actually stored. Now from here, what we are keeping also another account is that we want to check in which instances of y train where actually y, the actual y, the ground truth is equivalent to y prediction. Okay, so here in this condition I'm checking that whether predicted value and y are equal or not. If equal, just put them in accurate rows. So I'm trying to find how many accurate rows the my NP neuron is able to identify when the threshold was 3. Okay, now once I have this, I'm just going to print the accuracy with respect to that. So I will just put accurate rows. Okay, and if you want to know the in the terms of percentage value that how good it is and all that, you can, what you can do is, if you know the accuracy, that is number of correct predictions, which is in this case is accurate rows, divided by total number of prediction or total number of instances for which the our model has been predicted. So that is the number of rows of the training data set. So if we try to run this, so okay, so what does it means is, in the training data set earlier we have seen that a training data set has 512 rows, out of which it is identifying only 80 rows as a correct. That means it is giving me accuracy of only 15%. Okay, so that means that this b equal to 3 value might not be good for me. I need to identify some better values of or with respect to that. So how can I do that? So let's automate this thing as well with respect to a little change of changing. So what we can do is, let me write another code. So I will just copy this whole code here. Okay, and I will add that. Now I need to find the value of b which is suitable for me, right? So what I will do, I will I will use a brute force approach. That means for each value of b, I will try to traverse from 0 to the number of total number of features. How many features I have? 30. So I will 0 to 30. I will travel from value keeping b value as 0, p value as 1 till 30 and see that for which value of b I am getting the best accuracy. Now how to do that? So I will write a loop for b in range of x binarized train dot shape 1. Shape 1 means it will give, if it is 0 it will tell about rows, and if it is 1 it will tells about the number of columns. Okay, and plus 1, that means it might, you know this, right? The column number starts with 0, not from 1. So if even you have 30 rows, you will give 0 to 29, but actually the number is 30. That's why we are adding plus 1 in this case. That says that it will say from b value from 0 to 30, and I will add these two rows, I add these two lines as well, by pred, and I will just put all this other rows as it is in the in this for loop. So what you will do for each value of b, I am going to trying to understand which one is giving me better value. So to do that also, which b value is giving better this thing, better accuracy, I will just print out this, I will just print down the accuracy, and I will just print another value, that is b, for which b value I'm getting better this thing. So let's run this. Okay, now if I want to observe you, I want everyone to observe one thing about it. Now for 0 to 30th value, that is number of features, because you can't have a threshold greater than 30, right? Because the basic the function of MP neurons aggregate function, that is just summing of the values of an input. So you can't have 0 to 30. But what we're observing here is that when you don't put, if you don't put any threshold, that is the threshold is 0, if any value is greater than 0, it is giving me 62%. That means it's still a random. If I don't put any threshold, just randomly I will ask whether it's there or not, whether the output is malign breast cancer or the benign breast cancer. It is telling me that 62% of the time this thing will be correct. But what I am seeing that whenever I'm putting other threshold, my model accuracy has been decreased and little bit increased, but to not to extent. It is still, it's 30, 37 or 35% accurate. So there might be problems somewhere. So here, if here what we have to do, once you get this idea, then let's start again looking at the data itself. From data we might understand that why the problem is, from where the problem is actually arising. So let me show you the place where actually the data problem is arising. So we'll go to beginning of data exploratory here. Okay, now here I want to observe one thing. Now wherever the, so just look at this value of mean radius. Mean radius of class 0, whatever the mean radius value is greater than for class 1, which is 12 point something. Similarly for mean texture also the value is greater than 1. For mean parameter also the value is greater than the class 1. So likewise rest of the things also you might find that some way or the other, that whatever the values you're getting for class 0, those values are actually higher. Whenever they are higher, uh, their mean value higher, and they are actually higher than the class, whatever the values which are present in the terms of the mean with respect to the class 1. Okay, but what we have done earlier here is, when we are trying to binarize the output into 0 or 1, that means we are saying that whatever the values in this, whatever the value less than 1000 I am keeping as value 0, and whatever the values greater than 1000 I am keeping as value as 1. But actually in the data set it should be like, based on whatever I observe in the data set, it should be like whatever the value are less than 1000 it should be class 1, and whatever the values above 1000 it should be class 0, right? Because the class 0 values for any feature is typically higher than the class 1 feature value, right? So that's where the actual problem starts from us. So when we trying to do for X bandarized train, what we're doing is for value 0, for lesser values we have assigned the class 0, but at least we should assign class 1, and for whatever the values which are higher than certain threshold, it should be class 0. Okay, because that's the nature of the data is like. Okay, so that's why we can now we are going to change the label here in X bandarized train, and again we are going to run this. Same for test also, we are going to change the labels. So I hope you're getting the understanding of like that. The earlier presumption for us that if the value is higher, we are earlier we are putting them in class 1, and wherever the value was lower, we were putting them class 0. But now from the original data we find that actually the higher value should be assigned to class 1, and the 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 class 1, which is the malignant breast cancer, it actually has less values comparatively. So we should actually assign lower values, less than 1000 value, into the class 1, and above 1000 as a class 0. So we just shifted this labels directly here, okay, as 1 and 0. So whatever the lesser values in the features will be, it will assign as class 1, and whatever the features assigned greater than a certain threshold, it will assign as class 0. Now we will see the effect of it, how it is going to affect our code or as a NP neuron. So let's again run this code now. Okay, I'm getting some error. Didn't contain loop. Why it is like this? Okay, X binarized train. Okay, sorry, my bad. After converting, I need to convert into numpy array as well. I didn't do that, so again I run this. After running this, if I run this cell of actual NP neuron, we might get some better value. Yeah, now if you observe one thing here, earlier, if you remember correctly, our values was actually 0.3237 kind of like that, and the threshold of 0 is giving us best accuracy value. But now, since we change the labels where we are lower values are assigned as class 1 and higher values are assigned as class 0, we observe that the accuracy has been increased. So we can see that for maybe B as threshold is 28, we are getting 0.84 as a accurate value, right? Which is pretty good compared to the whatever we are getting as 60. From 60 to 84 is quite a big jump with respect to us that. So in crux, what I want to express is that when you're trying to train a model and going to do that a lot in during this course and all that, if you find that your values are seeming unreasonably low, the accuracy is unreasonably low, again go and try to understand the nature of the data set and how you're trying to pre-process the data set, because that's where the actual problem will lie, and from that you will try to change, tweak your model accordingly to train the relevant values. The moment I change the values of label, the wherever the in the dataset wherever the value is less, I'm assigning as a class 1, the accuracy of the model has changed drastically. It has increased by 20% more extra, right? From 60 to 80 it has been there. So it's a quite a big jump with respect to that. So that's what I'm going to, with respect to this, I'm going to tell uh, about NP neuron. Another way to just right now we have wrote as accurate rows by x divided by binary train shape and all that, we have written it manually, but there's a function for that also which you can use it for inferencing, that is basically for understanding whether your models did good or not. Okay, and now again, now this one more thing I want to show you while writing this code, whatever the value accuracy you got, this is for training the model. So after training the model, you're trying to see how accurately it is able to predict the trained data set itself. Now we have to see for test data set as well. So let's see that. Now to do that, to get an accuracy, we will use something called as accuracy score from sklearn metrics. So let me write the code here. Accuracy score. Okay, let's define it, and let's assume, just to give an example of again, um, instead of this I will just give you for this example better, just to show that, because the accuracy as a metric that we use a lot and talk about a lot to tell about how the data is look like. um, so let's say, since we know that now our threshold is 28, so we'll put B as a 28 only, and instead of, now we're going to try it on test data set. Okay, now we don't need accurate rows or any other thing, and we might not need y test or y train as well. So let's remove certain part of the code. Now we're going to test, we're going to see the performance of our NP neuron in the testing data set. Now y pred is equal to np sum x is equal to b, that's okay. Now it's y pred test dot append y pred, and accurate rows is not needed because we are going to use accuracy score as it is. uh, so accuracy will be like accuracy equal to accuracy score y pred and test and y test. So let me explain what I have written here. Okay, so accuracy score is basically is the function that we are calling. Okay, and we are storing the value in a variable called accuracy. So the first variable that you have to pass is a predicted value in from the test data set. So y pred, y predicted value of test data set, and the ground truth, which is y test, as a second variable. So now it is going to compare, and it is going to tell me that what is the accuracy of my model. in the on the testing data set. Again, I'm emphasizing on testing data set again. So I will explain why. Now here you can see in testing data set I am getting 94% accuracy, which is pretty good. But here I am getting max for training data set, and the maximum accuracy I am getting is 84. Now the reason is the difference here is because the the model, the way model has been trained, there still might be chance that it might have learned certain class pretty well and is able to identify that particular class either 1 or 0 properly, and maybe for 0 it might be doing here and there, right? So it is pretty common that you find that the accuracy of your training accuracy and your testing accuracy differ. Sometimes it happens that your testing accuracy might be lesser than your training accuracy, right? In this case, the training accuracy is greater than the testing accuracy. So it is pretty normal, because the kind of data has been split is not in your control, right? You can control to a certain aspect only, not more than that. So that is one thing that you need to keep that in mind. Low number of test cases might be one of the reason. uh, yes, you can say that there's no much diversity, but still, even that case also, even you have lot of data as all, still the training and accuracy will not get exact same value. It will be differ for sure. Okay, now only I have time for do section 6 only, but if I will write section C in the class, like I will try to write as a Python class. Now the reason I'm going to do is because the same way, whatever the function we're going to write for neuron class, we're going to write for perceptron and any RNN, backpropagation algorithm and all those stuff. So I'm going to give a template based on that. I'm going to put that, and if you want, we might stretch for perceptron, otherwise we might end. But I will give you, after the recording is over, I will give you the whole code for perceptron class as well. And but maybe in the next session, but I will talk about epochs, checkpointing, learning rate for sure. I might not cover that today. Okay, so but I will tell you that what is the importance of these things: epochs, checkpointing and learning rates, which is basically called as hyperparameters. Right now we are dealing only with the parameters of the learning algorithm. The learning algorithm for NP neuron was the only was B. Okay, for for perceptron it was W and X as a parameters. So W and B, another B is there which is not present here. So that two parameters are there for that, like here W and B, right? So maybe I will discuss that in next session. I will not codify at that point of time. I will just show you the code and I will explain you briefly. But today I am going to tell you the template of how to write a proper function and a class for any machine learning algorithm you are going to write in Python. Okay, uh, it is good if you get practice of this and try to put that in the maybe in the next upcoming sessions also. Whenever I'm going to use any new DL algorithm, I'm going to follow the same template. So let's start with this. So first function is usually in so it's a class NP neuron, we're giving it as a name, and first function is usually the initialization, which we'll call as underscore underscore. There are two underscore in it, which is called initialization, again underscore underscore, and then we this variable called self, which is self, basically just to get to know that self is a class variable assigning to itself. Okay, you don't need to dwell into this if you don't know much Python. Okay, uh, but this just to understand that this is a initialization phase, a kind of constructor, if you know some of the coding from your C and Java. So once we initialize this, it has to be there for, and whatever we're going to initialize, it is for the parameters, because we are going to learn parameters here. Then there's a function called model. We are going to pass self, that is a variable of class variable, and x will be the training data here. Small x, not small x, basically the instance of that training data set. Here we are going to pass from the model the function. Model is basically a mathematical function. If you remember the last class of your, some of you attended of 6, I talked about 6 charts. I may again come to it maybe in the next session. So in that, model is basically a function, a typical mathematical function. So for what is the function for MP neuron? Summing of all the features present in a for a one instance of a training data. So sum of x, sum is a function which I am going to define again, and if it is greater than self dot b, which is basically a our hyperparameter, see, which is a parameter or threshold. So this is another model as a function. The third function we are going to have is, in this case, predict. Now predict is basically once your model has been trained, it will predict your value. So let me write y equal to as a y as a one list, and for each instances in the training data set I am going to find result. You can take training and testing also, that is on your choice. And once now I will call model for this instance, and whatever the result I will get, either a 0 1, I will get it in result, and I will append that value in y. So y dot append results, result, and then I'll just return the y as a, I'm going to convert that as a NP array. Okay, just numpy array, just for the sake of convenience for us right now. No need to dwell right now of that. We might go a little bit, when we go little bit deeper, then I will tell you the importance of numpy array and all those stuff. Now the main function is fit. Actually fit is your learning algorithm. Okay, here actually the model is going to be trained, so you have to pass both x and y, and I'm going to write for accuracy and all also. So let's keep this as it is right now as a dictionary. This is a called dictionary. Now for a b, like we have seen earlier that b value, we are changing b value and finding the proper threshold value, because that's a learning algorithm, right? So b in range of, so whatever I wrote earlier, I'm writing same thing but in a little different format. That's it. X shape 1 dot 1. So from B we have 30 features in the breast cancer data set. So from 0 to 30. Okay. Now I'm going to assign the value of B one by one to B, and then I will call ypred, and I will call the function called predict. We are going to pass the value of x. So again you can check that x value has been passed here, and it will again call the function called model, where you will find the g function that you have seen in the theory lecture, that is summing of all the feature values. Okay, and we have for particular b, since self dot b is there and we are writing within the class, whatever the value I am writing here as a b, the same b, suppose the b value is 10, the same b 10 value will be available here as well automatically. Okay, so that's why self dot b is important for us. Once I get the value and I'm putting that in ypred, I'm going to call accuracy b. Now accuracy b is equal to for a particular threshold value, I am getting accuracy score, which is the function that we had defined earlier from the sklearn matrix. I am going to see the what is the accuracy score for the particular threshold value b. Now once I get this value, okay, let's see till here. This is the function that we can define here typically properly. Okay, after that I will add some more lines of code to give you much better understanding. Now once we define fit function with basically from here you're actually calling here basically it's going to learn all the parameters about basically b here, and from here fit function it is calling predict function, and from predict function it is calling model function. Model function tells about the mathematical equation which NP neuron deals with. Now to use this we need to create an object of class, so I'm naming as MP neuron in small case, and I'm just calling the class. So if you don't know Python, please learn Python during the course of this time, because most of the code, almost all the code we are going to do in this course, in this introduction session or in the NPTEL, will be written in Python. Okay, now I will call neuron dot fit function. Okay, so NP neuron fit function, and I'm going to call the fit function, and I'm going to pass since binarized version of the data set. So I'm going to find binarized train and Y train. Okay, that is the values will be 0 and 1. Now, okay, now once is there, I need to print the accuracy as well, right? So in the fit function, what I will do, uh, I will in fit function itself, I will maybe print as um, value of b as okay. So one more thing that we need to take care of is we need to find, okay, how do it might find proper b value for all this stuff. So I might need to add, I need to know that for which value b I'm getting the maximum accuracy. So for to do that, what we need to do is I will just add one more code here. I will try to find best b, which is will be the maximum of uh, accuracy which I am getting here, accuracy, and since the value accuracy dot get. Okay, so what I am trying to do here is accuracy is basically a dictionary. Dictionary means for each when dictionary will look like this. So it will be like dictionary will be like uh, 1 and let's say 90. Okay, this is a one value, another value 288. So like this a dictionary will be arranged properly, a rough dictionary. So what it has key and this is 90 will call as value. Okay, so what we are going to see that accuracy is, since it is a dictionary, what we are storing here is for each value of b which can be 0 to 30, 0 to 30, and uh, what is the value accuracy I'm getting for that particular b value. So that's how I'm storing here. So for maybe for one b value b equal to 1, I'm getting 90% accuracy. For b equal to 2, I'm getting 88% accuracy. Just like that I'm getting. So once I get that dictionary value, I'm calling the accuracy as a dictionary and I'm finding using max function the highest value as a accuracy that I'm getting. Okay, now uh, once I'm having this self dot b as best b. So I'm just assigning the whatever the maximum value I'm getting right now here, whatever the maximum value I'm getting here, I'm just putting as a b value. Okay. Now once this is done, I okay, signal is lost. Am I audible? Okay. Am I audible? Okay, okay. Okay, fine. Uh, so once I find the best b value for which I have the highest accuracy, let's print it out that as well. Highest accuracy is accuracy called best b. Okay, now once this is done, let me recompile it again and I will just do this. NP neuron spelling is wrong. Okay, okay, just let me this. Okay. Okay, so in this case, for this value, what I'm getting is for B27, I'm getting the threshold 27, I'm getting highest accuracy of 0.8574, which is pretty obvious. I think from our list also, uh, here also earlier when we did it manually, we found that for 27th position, I said wrongly earlier 28, but this is at 27th position, I'm getting 85% of accuracy, which is pretty good for our use case, right? So, uh, so maybe I will stop here. Maybe I will take some question here. Uh, okay, one more thing I need to do, right? This is done for training and training data set. I just need to do for, I'm just need to predict for testing data set as well. So I will just do that, just 2 lines of code, just let me write it here. So I just need to call certain functions. So y test spread uh, NP neuron. I will just call predict here. I just need to do predict, and I will just call the x binarized test, and I will get the value as, I just need to print the accuracy score. So I will just do print um, accuracy score y pred test and y test. NP is not defined. Oh, my bad. Okay, so from testing also I'm getting 0.94, which I can validate it from our earlier code also, which we wrote here, which is equivalent to, for b equal to 27. Oh, I should write 27 here instead of 28. It's still giving me good accuracy, right? So it's a kind of same accuracy that I'm getting. So what we can, to summarize what you can see from this code is, the way I've written a class for NP neuron, same way we're going to write for perceptron, RNN, CNN, and all those stuff. So it will have following functions: def model with mathematical prediction, mathematical model of that uh, uh, DL model we were talking about, that is NP neuron. Okay, there'll be a predict function, there'll be a fit function which is going to learn the parameters. The only thing which is going to change and this all this stuff is the content within this function, which is basically about the how the learning algorithms has been designed, right? If I'm going to write for perceptron, the content of fit function will be changed for sure. So that's what with respect to the NP neuron class. So what we have seen in the second session is, we started with, okay, we have started with that, okay, once we get the data in our defined format of 0 and 1, we started manually typing the NP neuron function, and we tried out for some sample value, that is in this case b equal to 3. Now after that we found that b equal to 3 is not suitable, so what we are saying we are doing is, we are finding the, by brute force, since the data set is less and the features are less, I can do brute force, and I'm finding that from 0 to 30 I'm trying to find the value of b, because within this range only my b value can be. So from that I'm trying to find the threshold of b, and from this I'm trying to find which b will give me best accuracy. Now once we do that, I gave a certain template in this class of class MP neuron, where you have to define certain functions, and that you have to modify your functions based on the whatever the new model you're going to add upon. Okay, what I will do, before taking question, I will tell you, and maybe before uploading this uh, code, obviously you have this code, you can save it also, or keep this open. Maybe for certain time I will add the perceptron code and all. In the next session I will just discuss what is epoch checkpointing and learning rate. Okay, I'll just code, I will not code it, I will just describe it, and maybe I will take some other topic at that point of time. And uh, and obviously I think a recording of session, the YouTube link, the playlist link has been given, so I will upload in the chat section, I will upload the recordings there as well. Okay, I'm going to use the same way, the way how I wrote the NP neuron class, same way we're going to use for perceptron as well. So that's the end of session from my side. Before taking the question, let's see some messages if we have anything. Yes, okay, so I will be taking every Tuesday this class from 6 to 8, and I will mostly dealing with the coding aspect of the course, where I'm trying to, whatever the theory I'm looking at it, I'm going to try it out to put it as a code. I'll show, for sure I'm going to discuss perceptron learning algorithm. I will not code it though at that point of time. I will just, what I will try to explain it how we can code this whole algorithm properly within using Python. Okay, and how the use of epoch checkpointing learning rate will improve our model learning as well, because these are something called as hyperparameters. To okay, um, yes, I will upload the code also. So in the description of the YouTube link, recording link only, I will give this collab link as well. Yes, instead of in section 4, you should use section 5 only as a inference. That is true. I just to get an understanding that how actually accuracy work, I just code it out at that point of time. But actually, you need to use directly the sklearn metrics kind of thing. This is the most preferred one among all of other metrics. Okay, so that's the end session from my side. I totally understand that if I'm not able to get most of the code and all that, and if you're new to Python and the deep learning stuff and all, but take your time, write the code on your own. Okay, you get some better understanding. Check the references from the internet from time to time. You'll get the understanding proper better, because the format in which I'm coding right now, same format I will try my fully best to apply the same kind of thing in the next sessions also, for when we are trying to build any concept, when whatever we learn in the theory part. Okay, so I am stopping the recording right now. Okay, you can ask the question after writing the code next week also. Sure. That is totally fine. That is pretty good also, if you're trying to code, do this. Okay, so in that case, I'm stopping mm, the recording. Let me go this side. Okay, I'm going to stop it.